Good morning, everyone. Myself Gautam Sharma, and I welcome you all in a Sapience Education. For further more details, you can also visit our website www.sapienceeducation.com. And if you want regular videos and all courses, and then you can also download our app. The link of the app for Android or Apples or whatever you are using. Already I have given the link. You can directly download our app so that you will get regular updates and all. Okay, so today I am going to teach you about class 11's physics laws of motion part 5. Subtopics are basically we will discuss about friction force and rolling friction. So what is friction? Friction is the opposing force that is set up between the surface of the contact when one surface slide or tends to slide to the object, to the another body. Okay, let us consider this is a body. Okay, let us consider this is a body. Understood? Now if I have kept this body in this surface like this, and if I want to pull this by the help of force P, then what will happen? This surface will oppose, definitely this surface will oppose its motion, and that opposing force is known as frictional force. That opposing force, red color, red color indicates frictional force, right? So whenever any two bodies are in a contact and one body is moving up, or then another body may apply in opposite direction of the friction force. Understood? So it will always oppose, so why does friction force arises? The reason we should try to understand why actually friction force arises. So let us show you by a diagram. Okay, if I will go for a diagram, then see there I had written block and a surface. So if you will go for microscopic view or magnified view, then what will be the view? See, we know that surface is a plane, but actually surface it is not in a plane. So surface has a structure like this, and even object's structure is like this. Okay, so when I will keep this object to the surface, then what will happen? See basically what happens when object is kept on the surface. What happens? See, let us consider this is a surface, right? An object is kept, so what will happen? See, they get interlocked, right? They get interlocked. So this object, when it is kept at this surface, they get interlocked. So this is a interlocking. Okay, and if interlocking happens, then what will happen? It will oppose the motion, right? And there is another reason, that is the molecular force of attraction. See, when this object is kept, then there is a molecular force of attractions between these two objects, and when this molecular force of attraction happens, then there is a large force which does not wants or tends to make this body in a motion. Understood or not? So whenever I will start pulling this object, so there what will happen? There will be an opposing force. Why? Because of the interlocking, and another is your force of attraction between the molecular level. Okay, so force arises on the account of strong atomic or molecular forces of attraction between the two surfaces, and the second is your interlocking. Understood? So see, interlocking or strong bonds always happens when it is kept in a static. When an object is kept static, then what happens? When an object is kept static for a large time, or duration of a time is very large, then what happens? There is an interlocking factor which increase the friction is due to the interlocking, and another is your molecular force of attraction. Okay, so it means that there is a very large force in a static. Static means when a body is in rest. Body is in rest, then static friction works, right? I hope you all have understood why this happens. Okay, So friction, why friction happen? Due to interlocking, due to the microscopic molecular force of attraction. Okay, so which is not seen in by naked eyes. Now I will teach you about types of friction. So how many types of frictions are there? So first one is static friction, and second is your limiting friction, and third one is your kinematic or dynamic friction. Now three friction can be seen in a single diagram only. If I want to show you in a single diagram, then you will able to understand what it is. Okay, so see, let us consider an object is kept on the surface. What happens? Try to understand. When this object is kept on the surface, what happens? What happen? You apply a force. So when you apply force, so force, suppose there is a 5 Newton force. So how much friction force will be applied? 5 Newton. Okay. And if you will increase by 15, then friction force will also apply a friction force of 15. Understood? So till the body is raised, the friction you applied is known as static friction. Till the body is raised. Okay, so try to read there. An opposing force that comes into play when one body tends to move over the surface another, but the actual motion yet not started. So many times what happens, you try to move the object, but object does not move because the frictional force is acting. So till object does not moves, then the friction force applied by the surface on the object is known as static friction. Okay, now if I will again increase it by 150 Newton, is it that the 150 Newton will friction force will be applied? It depends upon the situation. See, the friction force has a limit. Okay, friction force has limit. After certain limit, it won't able to apply the friction force. Friction force has limit, right? And after that it won't apply a force. For example, 5 Newton you have applied, friction force increased to 5 Newton. 15 Newton I have applied, friction force also increased to 15. And when I make this force as 150 Newton, then frictional force applied is only 50 Newton, because it has the only capability of applying of 50 Newton force, and this 50 Newton force is known as limiting friction. This friction force is known as limiting friction. So if the applied force is increased and the force of static, see here, force of static friction also increase, and if the applied force exceeds the certain maximum value and the body starts moving, after that, see, if I have a limiting friction force, for example, there is a body, okay, and the friction force maximum it can apply is 15 Newton. Okay, after that if you will apply 1 Newton, then what will happen? Body will starts moving. If I will apply a 51 Newton, then what will happen? Body will start moving. It means that the amount of force applied is just greater than the limiting the maximum friction force applied by the surface is known as limiting friction, and after that it won't increase. Understood? Now one thing I want to make you one clear, that static friction force is known as self-adjusting friction force. Static friction is known as self-adjusting friction force. Why it is known as self-adjusting friction force? Try to understand. See, till body is at rest, let us consider this body is there, okay, and I am applying force of 10 Newton. So friction force is being applied also 10 Newton. If I will apply to 20 Newton, then friction force will be applied also 20 Newton. If I will increase to 30 Newton, so it will also increase to 30 Newton. The more the amount of a force being applied is equal to the friction force, still the body does not move. And this is called self-adjusting force. Self-adjusting force, because friction force automatically adjusts its force. It is not like that if you are not pulling an object will get a force or friction. No. Friction force will always act when we will try to apply a force on the object, then only friction force start or come to the play. So I hope you have understood now. Static friction you have understood. Limiting friction you have understood. Limiting friction is the amount of friction till the limiting friction is the amount of friction till after that you cannot after that it cannot a body cannot apply more force, more frictional force, or a surface cannot apply more friction force on the another surface friction force. Okay, I hope you all have understood now. Now I will come to the kinematics or dynamics force. What is kinematics and dynamic force? Simple. When a body starts moving, what happens? The frictional force applied on the body is known as kinetics or dynamics force. Understood? Now I will make you understand all the three force with this graph, okay, and you can understand that which is the maximum force. See here what happens when I applies a force increased. So see, frictional force also increased. When I furthermore applied then frictional force also applied. So till, see here, till the body does not move, till this point body does not move, body does not move. Understood? And this is called limiting friction. Okay, after that when you apply a force, so body start moving, and you can see that from a diagram that there is sudden fall of the frictional force, sudden fall in the magnitude of a frictional force. Why this is happening you can understand, or you can also experience at a home. If you are applying a frictional force starting just when a body is in a rest, so you will get very hard. You need to apply a large force, but as soon as the body starts moving, then you require less force. Why this is so? Because when body is at a static position, then the interlocking is very strong and the molecular attraction of force is also very strong. Once the body starts moving, what happens? Once the body starts moving, what happens? See here, once a body will start moving, what happen? It will just hover. It will hover over this body. This hovering means that there is no interlocking is there. So definitely friction force or the opposing force will be less. Understood? I hope you have understood. So this region is your static region. This region is your static region. Okay, this region is your static region, and after this sudden fall in a amount of force you will get applied, friction force will become less, and you need to apply less force, and in this way, and this frictional force almost dynamic friction force or kinetic friction force works. So from here we got conclusion. What we have got conclusion, that we have got some conclusion that static frictional force, I am indicating frictional force static as like this. So static friction force is always greater than equal to, definitely try to understand, equal to means limiting friction force. So frictional force is always static frictional force is greater than equal to dynamic or kinetic friction force. Okay, see here, when a body is in motion. Okay, or limiting force, we can say limiting force is greater than equal to, greater than, generally we can say friction force, not required this. Okay, now how you will define numerically, how you will define friction force. See, now See, let us consider an object is kept on the surface. Okay, and it has mass m and the force acting is mg, and in the reaction force it will give r, and when I apply a force, it is called applied force. F is your applied force. F is your applied force. Okay, now what happens? See, there if I will apply a force, so friction force will start working, right? So now tell me which are the factors which depends upon the friction force. So frictional force is directly proportional to the reaction force. The more reaction force, yeah, normal force, some book they are writing normal force only. So the more reaction force or more normal force will be there, more force frictional force will be there. Okay, so I can represent it by small f only, because it is not the symbol of friction force. Okay, so let us see. So small frictional force is proportional to reaction force. So you can write here frictional force is proportional to reaction force, reaction or normal force. Okay, now another is your, if f is proportional to normal or reaction force, so f can we write here, I will write here r only. Can we write here f is equal to mu into r, where mu is your constant of proportionality. Okay, and this is called it is constant of proportionality, and this is called coefficient of friction. Coefficient of friction between surface. Okay, understood? I hope you have understood. So friction, coefficient of friction will be vary. It will vary and from one surface to another. For example, this is a surface A and this is a surface B. So there will be a friction force of mu AB. That is friction coefficient force of between these two body will be mu AB. Okay. So F is equal to mu R. So if you want to solve this problem, so what is R exactly? So from diagram we can see here R is a reaction force. So by using equilibrium equation, what I can write here, R summation of forces in y direction will be 0. That is equal to R minus mg is equal to 0. So R can be written as mg. Now you have written that friction force is equal to mu into R. So we can write the value of R here, mu into mg. So in this way you can find out the friction of any body. Okay, I hope you have all understood. So try to find at first reaction force and multiply it by the frictional coefficient. If there is no zero frictional coefficient, that means that it has no friction. Okay, now two types of friction coefficients are there. So we can go for two types of friction coefficient. First is your what? Mu s, that is your static friction coefficient. Static friction coefficient. And another is your mu k, that is your dynamic friction coefficient. Okay, so you will get to know you need to find kinematic friction force, you need to find static friction force. So wherever you required, you just use, if it is your kinematic friction force, use mu k into R. If it is your static friction force, you write here mu s into R. The definition of the formula will be same. See, formula of both the friction force are same. But the only thing is that here kinematic coefficient of a friction is replaced by static coefficient of friction. Okay, so in this way you will able to do this. I hope you all have understood this. Now I will talk about angle of friction. What is the angle of friction? So try to understand here. Angle of friction is what? The angle at which resultant of limiting friction and normal makes with the normal reaction. Okay, the angle which the resultant of limiting friction and normals makes with the normal reaction force. See here, this angle is called angle of friction. So this is your limiting friction and this is your reaction force. So how to find a angle of friction? So we need to take, at first, see here, if I will make this as a triangle, so you know that this length is your what? This length is your reaction, and what is this length? Or this length is your limiting friction. So if I will consider this as a triangle, so what will happen? Tell me. Base is your reaction and perpendicular is your limiting friction force, and theta is your angle. So tan theta is equal to tan theta is equal to tan theta is equal to perpendicular by base, that is equal to limiting friction by r. Okay, now FL by R. Now just now I have given some formula that FL or limiting friction force FL is equal to mu into R. Okay, now from here we can we write here tan theta is equal to mu, or theta is equal to, it is your limiting friction or static friction. I am telling you can write here static friction only. Okay, ms. Okay, so tan theta is equal to mu s. So theta equal to, why it is like this? So theta is equal to tan inverse mu s. So this is called angle of friction. I hope you all have understood this. Now I am going to teach you another topic, that is your angle of repose. What is angle of repose? It is defined as the maximum angle of inclination of a plane with the horizontal at which body placed on it just begin to move down or sliding down. How see here? Let us consider an object is kept in this horizontal table, so no slidings happens. But if I will increase its angle, so what will happen? It may try to slip, and the angle at which just start slipping is known as angle of repose or angle of sliding. So see here, in this object just start moving down. So which type of forces are acting here? I have already teach you in a free body diagram. If it is your mg is acting downward, so can I resolve this mg into the component, that is your mg sin theta and mg cos theta, and there is always a reaction force on the perpendicular to the surface, and there is a force here. Okay, mg. Now what happens here? When it start coming down, so frictional force will act. Yes or no? Yes or no? So frictional force will act in just upward direction. Why? Because body is going to move in a downward direction. So frictional force is an opposing in nature. so it will act in a upward direction. Okay. Now by using a equilibrium equation, can we write here, by using equilibrium equation, can we write here Fx equal to 0, that is equal to frictional force minus mg sine theta is equal to 0, or we can write here F equal to mg sine theta. Okay. Now reaction force, by using a summation of force in y direction, we can write here our reaction force minus mg cos theta equal to 0. From here we have got r is equal to mg cos theta. Now as we know that frictional force is equal to mu into reaction force, so can we write here friction force is equal to mu into mg cos theta. Why mg cos theta? Because we have got the values of r here, we have got the values of r, and which is your mg cos theta. Okay. Now we have got frictional force, we have a two equation, that is equal to one equation, this is your one equation and this is your two equation. Okay. So if both the friction force we are talking about same thing, so can we equate 1 and 2? Equate 1 and 2, what you will get? Mg sin theta is equal to mu mg cos theta. So m got cancel, gg got cancel. So what we are talking about? Sin theta by cos theta. Sin theta divided by cos theta is equal to mu, or we can ultimately get tan theta is equal to mu, or theta is equal to tan inverse mu, and this is the angle of repose. This is the angle of repose. Understood? So angle of repose, theta is equal to tan of inverse mu s. So if in any question, if they will give you mu s values are given and they try to find out the angle of repose, so directly you can write here angle of repose, that is equal to theta is equal to tan inverse mu s. This is the sufficient to get the answer. Okay. Now from above we have seen that just now we have derived angle of friction, and just now I have derived angle of repose. So from here we can write here we can get a conclusion that angle of repose is equal to angle of friction. Okay. So now I am going to discuss about rolling friction. What is rolling friction? See, already when we start moving an object, lots of friction is acting. Okay. So lots of friction contacts are there. So we want to reduce the friction. So reduce the friction. Okay. And if you want to reduce the friction, so you need to decrease the contact force, and the rolling method is the best one where friction force can be reduced. So when an object such as wheel, disc, ring, where a sphere or cylinder rolls over the surface, then the force of friction that comes to play is called rolling friction force. So when it moves, so rolling friction force will oppose its motion, right? So rolling friction is directly proportional to the normal reaction force. The more normal reaction force will be, the more rolling friction will be there, and inversely proportional to the radius of the rolling body. If more radius is there, less friction will be there. If less radius is there, more friction will be there. So F rolling is directly proportional to normal reaction force and inversely proportional to radius of the body. So we can write here F rolling is equal to mu into r into n by r, where mu r is the called as a coefficient of rolling friction. This is what friction force is all about. I hope you all have understood about rolling friction force. Now I will solve some problems so that you will get to understand how to solve the numericals of the friction. Now, question I am taking is your question number one. It's an example of NCRT book, and this is your example 4.7. See, they are telling about determine the maximum acceleration of the train in which a box lying on its surface will remain stationary given that the coefficient of the static friction between the box and the train is floor is 0.5. A box is here and it is being kept here. It is kept on the floor of the train. Okay, so see, let us train is moving in this direction. So, and a train is having an acceleration of a. Okay, now frictional force will be being applied as like this. Okay, now see what happens in this question. They are telling that determine the maximum acceleration. Suppose acceleration is a and static friction is what? Fs. So our force applied on this object must be less than frictional force or static frictional force. Now force is equal to ma must be less than equal to what? Static frictional force, that is equal to mu into mg, because frictional force is equal to what? See, it has a body, has a mass of mg, weight is mg, so reaction force will be r. So r can be written as mg and frictional force can be written as mu into mg. So by putting this frictional force and this mass into acceleration, we will cut here. So acceleration will be how much? So acceleration must be less than mu into g. And what is the values of mu? Values of mu is 0.15 and into g. So acceleration must be less than equal to 1.5 meter per second square. So this is the solution of this question. I hope you have understood now. Now again, another question I want to solve here. See here, a mass of 4 kg is raised on a horizontal plane. So let us consider there is a horizontal plane and how much mass it is? 4 kg. So 4 kg is there. Okay, and the plane is gradually inclined until the angle is 15 degree. So till 15 degree it is gradually angle is increased, right? Until angle is equal to 15 degree with the horizontal mass just begin to slide. What is the coefficient of static friction? So mu s is equal to what? Just now I have told mu s is equal to coefficient of friction is equal to tan theta, and here theta is how much? 15 degree. So tan 15 degree is the mu x. Okay, so by using this you will get the answer. Okay, I hope you all have understood. Further details numerical I will discuss in the numerical sections. So if you want to learn a numerical also, so you can visit the YouTube channel playlist where I have separately solved all the NCRT problem. Thank you once again and for watching my videos. I hope you enjoyed this session. For further more details you can comment. Thank you.